Yeah, I'm Martin Ostoja-Starzewski. I'm from the University of Illinois at Urbana-Champaign in the US. I'm in the Department of Mechanical Science and Engineering. I work in mechanics of materials. Yes, I participate in the program on certainly quantification in mechanics of materials, in stochastic modeling of mechanics of materials. The objective of the workshop is to take into account the variability in materials at various scales, as opposed to classical approach of continuum solid mechanics. So the key thing is to account for a large amount of data that we get through experiments and observations in the lab, also in general technology, and even general observations in the field. And on the other hand, to set up mathematical models. And models have to be of stochastic type. So it's a challenge in combining stochastic mathematics with mechanics of materials. My lecture will be set up from the standpoint of mechanics of materials of random media, where first I will focus on the problem of representative volume element. So that's the key basic concept on which continuum solid mechanics is based. And then I will point out the need to introduce fluctuations at one or more scales, microscales, and as a result setting up a random field model or models on so-called mesoscales. Meso means intermediate. And at that point, since all of continuum mechanics is written in tensors, I will talk about tensor random fields, both formulation, mathematical formulation of tensor random fields from very easy angle for general audience, and also informing those tensor random fields from the standpoint of experiments and observations. And at that point, I will try to make as many connections as possible with talks given this past week in the workshop by a number of lecturers running for 5 days last week.